Today we'll be exploring how the UK is adapting to our changing hydrological cycle. It is a complex system made up of inputs such as precipitation, outputs like evaporation, and stores such as rivers and groundwater aquifers. These are all interconnected, meaning that any change in one of the components will result in influencing others directly. For example, less precipitation in a drainage basin as an input to the system will directly influence the quantity of water reaching surface stores like rivers through transfers such as overland flow. Behind these changes there are both long-term and short-term factors which are driving these changes, disrupting the state of dynamic equilibrium in the cycle. This presentation will focus on how long-term climate change is putting pressure on several components of the system. These factors include human activity, such as in the industrial sector and deforestation, which both require fossil fuels in the process from driving chemical processes as well as machinery. The use of fossil fuels has increased dramatically from factors such as population pressure from population increase, raising greenhouse gas levels in the atmosphere as one of Earth's subsystems, amplifying the greenhouse effect. Adaptation is necessary to reduce harmful human activity and therefore the changes they have to our water cycle. The water cycle is changing in several ways. The Royal Meteorological Society have stated that the water vapour concentrations have increased by 3 to 4% since the 1970s. The graph to the left shows this trend as an overall from 1990 to 2010, where the amount of water vapour, though has fluctuated, has increased dramatically. This change in stores of this greenhouse gas in the atmosphere can induce a positive feedback loop as global warming can cause warm air to hold more moisture, increasing rates of evapotranspiration as an output in the cycle. This can intensify rainfall events and the frequency of flash floods as a result. This can be shown on the storm hydrograph to the left, where climate change can cause a steeper rising limb. Due to this and pressure from urbanisation increasing the impermeability of surfaces, over-abstraction of groundwater as times such as drought increase can create water stress in drier areas such as in the southeast of the UK. This causes an over-reliance on groundwater stores which depletes aquifers faster than groundwater recharge, especially if there is less infiltration from precipitation when soils harden in hotter periods of weather.
These are some of the ways that the UK are adapting to our changing water cycle. There's water transfer projects, transferring water from areas of surplus to deficit. There's also agricultural resilience, which allows farming to be more sustainable and work alongside the water cycle with efficient irrigation, like drip irrigation, minimising the loss by evaporation. It's also important to individually help and prevent it changing further. We can reduce our consumption with new technology measures and more efficient appliances. There's reservoirs which can increase water security, and regulatory and policy measures, and investing in research infrastructure to help ensure that we can adapt. Coastal and river flood defences and restoring peatlands can reduce flood risk and reduce the damage caused by it. The Haven-Thicket Reservoir is currently under construction and is scheduled to be completed in 2029. It will hold up to 8.7 billion litres of water, which will help adapt against our changing water cycle as it can increase water security by creating a long-lasting store. It aims to protect some of England's rarest chalk streams and use water recycling in the future, incorporating treated effluent from Budd's Farm sewage treatment plant. However, building reservoirs can have many environmental problems. It will remove 12.5 hectares of ancient woodlands. However, they plan to replant around 200 to offset these impacts. Haven-Thicket Reservoir will contribute over £50 million to the South East economy to create 84 new jobs.
Weather events caused by a warmer climate from global warming, increasing the energy driving evaporation, increasing the amount and intensity of precipitation as a result. This can overwhelm soil water stores as their field capacity is maximised. The National Trust is implementing the National Trust Peatland Restoration Project. This natural climate adaptation strategy aims to restore 590 acres of peatland in Wicken Fen, as it acts as a hydrological buffer in events of flooding to intercept rainfall and store it more efficiently than other stores in the cycle. Retaining rainwater and managing water tables is crucial in flood control and drought protection. As part of this project, they are also installing clay banks, another form of soft engineering to again enhance water retention and reduce runoff in storm events. The goal is to create saturated, sustainable peatlands across Wicken Fen to defend and buffer populated areas whilst protecting ecosystems from the long-term climate risks arising.
Climate change is influencing the stores, inputs and outputs in the water cycle, meaning adaptation such as restoring peatlands and building reservoirs is key to mitigate against the impacts, and this is shown with many UK examples.